Hey, and welcome back. So, today we're going to talk about two things. Something called the kernel and something called screen memory setup. So, let's start by looking at screen memory setup. So, I have started a little code example here. So, this is nothing special. I just have my basic upstart 2 here, my main, and just an RTS here. So basically this doesn't really do much. But down here at memory address 3800 I have crammed in my own custom character set. So just like before, import binary charset bin like that. So my custom character set is going to be put into 3800. Now, like I said before, especially when dealing with sprites and character sets, the memory addresses we choose is really important. So what happens now if I just run this code? So there we go. I ran the code and basically nothing happened, right? But because of this RTS, we broke out of the assembly code and now we're back in basic. Normal basic. So nothing happened, and I did not see. This is the default character set for the Commodore 64. So nothing happened. All right. So here's the thing. The Commodore 64 has a special memory address that we're going to take a look at right now. So memory address D1018. D018. That memory address is something called the memory setup register. Now, that memory address basically keeps track of two things. What character set we want to use, and this is something new. Where our screen memory is. Where is our screen RAM? Now, I haven't talked about this because I didn't want to confuse you, but it's possible to move where screen memory is inside the Commodore 64 memory. Now let's come back to that, why we would do that, but this memory address keeps track of those two things. So now I'm in the website that we've seen before, Commodore 64 memory map. Now, this is, as I said before, this is a really nice website because you can go and look at almost, I think, maybe every single special memory address for the Commodore 64. Like, for example, this one, D018. And you can see what that memory address does. In this case, it was the memory setup register. But even more importantly, we can see what the bits do inside this byte. So, of course, that we have our bytes that are 8 bits, and a memory address like D018. That's of course also 8 bits. It's just 1 byte, right? So each of those bits inside D018 has a meaning. So if we take a look at there, and don't forget, we're starting from the right. Bit 0, bit 1, bit 2, bit 3, so bit 7 is all the way at the left here. So what does this website say? Well, it says up here, bit 1 to 3 in text mode is the pointer to character memory. So by combining bits 1, 2, and 3, that's these 3 bits. So by using those 3 bits, we can make a combination, as you see here, 0000, 001, and so on. And any one of those combinations is going to point to a specific place in memory where the character set is. So this is, if you want to use a custom character set, we need to specify it here. Now, I placed my character set at address 3800. So 3800, that's this bottom one here, because here is the memory address for the character set. So I could have placed the character set at address 3000, 2800, 2000 and so on. But I chose to place it at 3800, which means that bit 1 to 3 needs to be 111. Alright, so let me do that right now. I'm going to change these bits to 111, because that means that the character set is located at address 3800. Alright, let's just jump down to this one. This tells me what bit 4 to 7 does. So bit 4, that's this one. So bit 4, 5, 6, 7. So those bits there at the left. What do those bits do? Well, they are pointer to screen memory. So once again, by combining those 4 bits, we can make some different combinations here. And here we can see where the memory is. Now this, of course, is familiar to us, 0400. That's the default memory address, right? That's the one we're used to. But as you can see here, we can have more, we can have different, we can have the screen memory at a different position if for whatever reason we wanted to do that. So by using a combination of these 4 bits, we can tell the Commodore 64, no, my screen memory is not at 0400 anymore. I want to use 0C100, for example. Now, right now, this probably doesn't make much sense, but for now, let's just accept that we can move the screen memory around. But right now, I don't have a need to do that. So I'm just going to leave it at 0400, because that's perfectly fine for me now. So if I want to leave my address at 0400, what's the combination of bits there? It's 0001. So that's what I have to write in here. 000 and then a 1 here. So basically now this tells us, so let's just say that let's start by these. So these 4 bits now tell me that screen RAM is at address 0400. We just found out that the combination of those 4 bits 0001 means screen RAM is at 0400. And we also found out that the combination of these 3 bits means that the character set is at address 3800. So I can't have these spaces like that, but there we go. And this last bit here, bit 0, is simply unused in this memory address. So what I'm going to do right now, I'm going to say LDA and a hashtag and this binary number like that. And then I'm simply going to store that into memory address D018, which is the screen memory setup. So by doing this, I'm now telling the Commodore 64, I want the screen RAM to be at 0400. I have a character set at 3800. Now, it's important, of course, that I actually do have a character set there. but in this case I do, so it's not a problem. So, alright, fine. What's going to happen if I save and run this now? Well, we didn't touch the screen RAM, so that's not going to be any different. But now I got this. So at least something happened, right? We see that the characters changed here. Now, the thing I didn't tell you was that my character set here is a multicolor character set. So I also need to tell the Commodore 64 that I want to have the screen set up for multicolor. Now, right now, we were working with address D018, the screen memory setup. There's another address just above that here, D016, so D1016. D016. That's that memory address is called Screen Control Register 2. I'm just going to call it Screen Control 2. So what that memory address does is a few things, really. One of the things it does is it helps us with horizontal raster scroll. Now, we are not going to be talking about scrolling now, and actually we're not going to be covering scrolling at all. So just a heads up. But if you want to use scrolling, there's this memory address has something to do with that. Another thing that this memory address does is it says something about screen width. So we can actually make the screen a little bit more narrow. So we could go from 40 columns, which is the default width of the screen, right? And we could go down to 38 columns instead. Now, the reason why, one of the reasons, at least maybe the main reason why you would go to 38 columns is if you wanted to use horizontal scrolling like that. But again, let's not worry about scrolling. So, then we get to this multicolor mode. That's bit 4. Alright, so bit 4 needs to be set to 1 to activate multicolor mode for the screen. Now, what's nice about this is that here we have the default value for D016, D1016. This is the default value for that. So I'm just going to copy the default value here, this binary value. And down here, I'm just going to say LDA hashtag, and I'm going to paste in that default value for D016. And these ones and zeros have a meaning, like we just saw. But right now, I'm more interested in bit 4, because this needs to be set to 1 to activate multicolor for the screen multicolor. Alright, so bit 4 needs to be set to 1. Alright, so we have bit 0, bit 1, bit 2, bit 3. So bit 4, that's this bit. This bit needs to be set to 1. So I'm just going to modify the default value here, and I'm just going to change this from 0 to 1. Because bit 4 needs to be set to 1 to enable screen multicolor, like that. Then I simply do like I did before. I say STA, store that into memory address D016, D16, which is screen control 2. So now I've told the Commodore 64 a few things. I told the Commodore 64 where I want my screen memory to be at 0400. I've said where my custom character set is. It's at 3800. But I also told the Commodore 64 to enable screen multicolor. Alright, So let me just also do something else. So we've seen screen multicolor before, and we know that there are two memory addresses for the extra colors. So we have extra color 1 and extra color 2 for multicolor. I'm just going to set those really quick here. So LDA black, and I'm going to store that in the memory address for extra color 1. So that's D022 screen extra color 1. I'm just going to load A with white, store that in D023 D1023, and that's screen extra color 2. So now I've set the two extra colors for multicolor. So now my character set, if it's set up with multicolor, which in fact it is, I am using the multicolors for this character set. So I have a multicolor character set here, and I'm using these two extra colors for that. So I set this one extra color 1 for black, extra color 2 for white. So it's going to match what I made here in ChartPad. Alright, so now I've set those two extra colors, but I also did this thing up here where I told the Commodore 64 where to find the character set and also enable multicolor. So by doing these things, what's going to happen now if I run my code? There we go. So now the Commodore 64 is using my custom character set. I also switched the screen to multicolor. So basically everything we did here worked just fine. And since I used RTS at the end here, I broke out of my assembly code and now I'm back in BASIC, which means that I can just start writing here. So now I'm using my own custom multicolor character set here, which is located at address 3800. So we just need to tell the Commodore 64 about all these things. And we need to remember that D1018, so D018, that's the screen memory setup. That's where we set up where our screen RAM is and where the custom character set is. We also have this screen control 2 thing, D016, so D1016. That's where we activate or enable screen multicolor. So we don't want high resolution mode for the screen right now. We want it to be set up for multicolor. So we need to change bit 4 to a 1 here. And this I just added color black for extra color 1 and white for extra color 2, because that's how I made it here in ChartPad. So I wanted it to look like this. Alright, so now, why would you want to move screen memory? There's not really just one answer for that. To move the screen memory like that basically has to do with how you plan your memory usage. So maybe you have some big thing that you want to have at the start of memory. So instead of having screen memory here at 400, maybe you absolutely need to have some sort of graphics there or whatever. And you move screen memory to maybe 0C100 because it's really important for your program that you need to have this thing at 0400. You know, it's really hard to give a great answer because the reasons for doing these things will vary from project to project. But there's another thing as well. We need to take a look at that. So once again, here we are looking at the Commodore 64 memory. So now we were talking about screen RAM, which by default is here at 0400 to 7FF. But we just saw that it's possible to move it up here or up here. You know, if we look at what this thing said, it's going to allow us to go from 0000, 0400, 0800, and the last thing that we can see here is memory address 3000C100. So we can place our character set all the way up here. Now, here's the other thing. You can move screen RAM around like that, like I said, if you have some sort of specific reason to do that. But what we haven't talked about is something called VIC banks. Now, we're not going to go into detail about this, but basically what's going on is that the Commodore 64 memory is split up into, let's see if I can get this right. I think that was right. It's split up into 4 parts like this. So let me just finish this. So maybe this should be a different color. I was really having a hard time picking the right colors now. There we go. So the Commodore 64 is split up into 4 banks, VIC banks. This is VIC bank 0, VIC bank 1, VIC bank 2, and VIC bank 3. So the VIC chip, the video chip, can only see one of these at a time. Which means that we have only been working with graphics in this area up until now. And we're just going to do that as well. But I just want to show you. And maybe I should write VIC bank 0 here. Just to make it a little more visual. Let's see. And this is VIC bank 1. This is VIC bank 2. This is, oh, come on. This last one is VIC bank 3. So, maybe if you do it that way, sure. All right, like that. Anyway, so the memory, it has split up like this for the VIC chip. So right now we have our entire setup for screen memory is here VIC bank 0, which means that right now I can't place sprites or a custom character set up here somewhere. I can't place a character set something up here now because the VIC chip can't see it right now. Because the VIC chip is configured for this memory area. So you can, the VIC chip can only see one area like this at a time. We have configured here, and our screen RAM is configured here now. We can't configure screen RAM up here, for example, over here, without changing where the VIC bank is. So how do we change where the VIC bank is? Well, oops, there is another memory address. Let's see here. There we go. So memory address DD00. DD00. That memory address keeps track of what WIC bank we are in. So we're not going to go too much into detail, but I just want you to know about this. So by changing 2 bits in this memory address DD00, you can say if you want the WIC chip to point at this bank, this bank, this bank, or the last one. So WIC bank 0, 1, 2, or 3. Once again, why would you want to do this? Why would you want to change where the WIC chip points? Well, at the beginning, probably doesn't make too much sense. Because as long as things are working fine down here, then there's really no point. But like I said, it has to do with how you plan out memory. So if you need to, for whatever reason, maybe you need to fill up this whole thing from address 400 and way up here. So for whatever reason, you need to fill that with something. So you don't want the screen RAM to be here. Then you could, for example, change screen RAM to be here, in this area. So you would have to change where the WIC bank points, and also by changing the WIC bank, let's see here. We also have this in D1018, where we set the pointer to where the screen RAM is. Now it says here 0400, the default one that we know about, but that's relative to the WIC bank. The thing that we just saw, we could set up a DD00, which means that, let's say we changed in DD00, that memory address, we changed that. We don't want to use WIC bank 0, we want to use WIC bank 1 now. Alright, so we changed to WIC bank 1. We did not change the D018 address, so the pointer to screen RAM. That's still at 0400. So like it says here, this memory address, screen memory address, that's relative to the WIC bank. So if we did not change this D018 thing, then this is still set for 0400, but now it's 0400 relative to WIC bank 1, which means WIC bank 1 starts here at 4000, so it's going to be 4004. So I hope that makes sense. Since it's relative, this where we place the screen RAM is relative to the WIC bank, what WIC bank we choose, then we need to just add this address to the start of that WIC bank. Hopefully that makes sense. But like I said, let's not go too much into detail about this, because at the very beginning it probably doesn't make sense. This is just something that it could be useful if you have a lot of data that you need to fill in somewhere, or changing where the screen RAM is can also be handy when making games. And if you're making scrolling routines, that's, as I said, we're not going to be looking at scrolling. It's way out of the scope for this course because it's quite complicated. But point here is screen RAM can be used for other purposes as well. So for example, you can have, let's say, a menu screen. You make a nice looking menu screen in Charpad and you paint that for one screen, but that could be at memory address, maybe you have your menu screen at memory address C100. So there's you have set aside 2 areas for screen RAM now in your project. One of those is the default 0400. That's okay. But then you also said, no, wait, I'm going to set aside 0C100 to 0FFF all the way up here. I'm going to set aside that for another screen RAM. So I'm gonna have 2 screen memories in my game. The reason I want to do that is because the one at 0C100 is gonna be my menu screen. So just by changing the contents of D018, the pointer to where our screen memory is, just by changing that, we can change the screens. So we don't need to load a menu screen and then load back the other screen. We can just flip where the screen RAM is. So the screen is going to be updated. So now I'm playing my game. My guy is running around on the screen. The normal gameplay. I'm at my screen RAM is at address 0400. Okay, fine. Now I'm gonna do something. Maybe press the space bar and I switch over to my menu screen. So by just flipping a few bits here in D018, the screen memory setup, D1018. Just by changing these few bits, and now I'm pointing at 0C100, that's the screen RAM now. Then suddenly, in a split second, I can see my menu screen. And by going back, so maybe I press the space bar again and I go back to my game, I change the screen RAM from 0C100 back to 0400. So hopefully you can see that it can be used that way as well, just to switch screens like that. Alright, well, like I said, I don't think we should go too much into detail about this, especially not this VicBank thing. But now at least you know that there's something there. So in case you ever have some sort of need, or if you have some special interest, then definitely read up on this. And like I said, if you're going to do scrolling, then you're definitely going to have to use these sort of techniques. So anyway, that's screen RAM. So we have screen memory setup where a custom character set is and where screen RAM is in D018. We also looked at D016, D1016, screen control 2, where we enable multicolor, or switch between multicolor or high resolution, whatever mode we want for our screen. So that's screen control 2, D1016. But we also need to take a look at some other address here called screen control 1, D011, D1011. So this also has to do with the bits in here also do a lot of stuff. And this also has to do with scrolling, but this time this address keeps track of vertical scrolling. Also, this also can change the screen from 25 rows tall to 24 rows. Once again, you'll probably want to do that if you're going to do some scrolling in your game. But then there's a bit here, bit 4 in D011, and that says screen off. So if you change bit 4 to 0, that's gonna disable the screen. So like it says here, complete screen is covered by the border. So you're sort of disabling the screen. You're maybe if you made some sort of system where you need to load something and you just want the screen to be disabled. You don't want anything displayed when you're loading your next level or whatever. Then you can just flip this bit 4 in D1011. Flip it to 0 and you disable the screen. When the loading is done and your level is ready, then you can just flip it back to 1 and you're enabling the screen again. So just a simple trick to disable or enable the screen. So like you see here, screen, if you flip it to 1, the screen is on, normal screen contents are visible. So there's also a bit here for if you want to be in text mode or bitmap mode. We're not going to talk too much about bitmap mode. We're probably going to take a quick look at it at the very end of the course. but not right now. I also mentioned the extended background mode. So we have high resolution mode, multicolor mode, and there's this third one called extended background mode. I briefly mentioned it, and that was sort of a mix between multicolor and high resolution, but we're not going to be using that, so we're just going to leave that for now. So the point here was that we do have especially these three addresses: D011, D016, and especially D018. Those three addresses, maybe we should write them. So okay, so memory address D011, which is screen control 1, and D016, which is screen control 2, and last but not least D018, which is screen memory setup. These three memory addresses are important, as I said, especially this one. You definitely need to know about this, because if you don't know about this memory address, then you're gonna have a hard time setting a custom character set in your game. And like I said, we enable a screen multicolor here, and there are some stuff in screen control 1 as well. We are not going to be using that too much in our code, but you need to know about these things when it comes to screen setup. Alright, I think that's enough for screen setup. So now let's look at the kernel. So before we leave this VIC bank thing, let me just comment that every one of these VIC banks is 16 kilobytes. So 16, 32, 48, and 64. So each VIC bank is 16 kilobytes. Alright, now the kernel. What is the kernel? Well, here in the Commodore 64 memory, we see that this last part, from address E1000 and all the way up to the rest of the Commodore 64 memory, that's something called the kernel RAM. This area. So what is the kernel? I briefly mentioned it before, but the kernel is a part of the Commodore 64 operating system. So there's a lot of stuff in here that just make things work. But there's also some stuff in there that's really useful for us as programmers. So finally we come to this screen clear thing that we've been seeing some examples of. So when I say screen clear in my code, screen clear, we've seen that a few times. That's this this memory address, E1554. So in other words, it's a memory address here in the kernel RAM. Now this screen clear, we can see that we are using JSR, jump to a subroutine, which means that here in the kernel RAM there's a subroutine defined by the Commodore engineers. So there's a subroutine defined in there which will clear the screen. Now we don't know what that is because of course it's located in here. Now if you're good at this sort of things, then you could poke around in the memory and you can find out how that works. But normally it's not something that we see. Just know that there's an address here in the kernel RAM that will clear the screen if we jump to subroutine at this address. So there are a lot of things like that in the kernel, and let's take a look at a few of those now. So like I said, in the kernel there are a lot of routines, a lot of things that will help us. So let's say we want to write something to the screen in our code. Well, you could make some sort of routine yourself. You could make your own routine to write characters to the screen. But there is a pre-written function for us that we can use, which is located in the kernel. It's called the char out. So it's going to write something to the screen. Now it requires a little bit of setup. We're going to take a look at that in just a second. But the point here is that there are a lot of stuff in the kernel that helps us as programmers. So once we're starting to load and save things from diskette, then this is super useful. Now again, you can clear the entire memory, disable the kernel, disable the basic RAM, you can disable everything. But that means that you have to make absolutely everything from scratch. Now, that can be a challenge sometimes. But if we want to do it the easy way, then there is so much that can help us here in the kernel. So let's take a look at this thing where we can write characters to the screen. That's going to be a good example of how we can use the kernel as programmers. So here we have a little example of how we can use things in the kernel. Now there's a ton of stuff in the kernel, so this is just a few of those things. But here we start by the thing we have seen before, my screen clear. So that's at address E544. So there's a subroutine in there which just clears the screen. Alright, fine. So we run that routine and then we're back here. Now, here comes the tricky bit. I want to write a character to the screen using the kernel functions here. But before I can do that, I need to use something called plot. Now the plot routine is just going to place, let's think about this as the cursor on the Commodore 64. So it's going to place the cursor somewhere on the screen where I want this character to appear. Now the way this works can be a little bit strange, but we have to use the carry flag in the CPU. So you remember the carry flag, this is one of those CPU flags in the CPU. And of course it can be 1 or a 0. It's just one flag, right? So clear carry, that's going to set it to 0. Set carry is going to set it to 1. So now I say CLC, clear the carry flag. And that function, let's see here. So the plot routine, we can see that here. So it says save or restore cursor position. Okay, so now I'm gonna set the cursor position. And you can read the details of how this works here. So you want to set or restore the cursor position. Yeah, I think that's correct. Anyway, depending on if you set the carry flag or clear the carry flag, the X and Y is going to mean different things. So let's get back to my example here. Now I said clear the carry flag, set the cursor position to output, okay? Set the cursor position, let's just call it that. And if I do that, then my X register is going to mean what row do I want to plot this cursor position at. And my Y register is going to mean what column do I want to plot it in. So here I say set the cursor at row 2 down and 1 from left to right. So I set those 3 things first. Then I run another subroutine in the kernel. This time it's placed at address FFF0. That's the routine we call plot. So first I need to do this little setup, and then I run this routine called plot at FFF0. Then I plot where the cursor should be. Now we come to something fun, okay? We need to look at something. So we have looked at our screen codes, right? We know that if we load A with 1, store it to 0400, top left corner of the screen, we're going to get an A up there. So we know about these screen codes. Now, there's another thing, very similar thing, called PETSCII codes. So you can see it's very similar, but it's not the same. So when we're working with a screen directly, loading something into the accumulator, just storing it in the screen RAM, then we need to use the screen codes. But when we're using this kernel function to write characters to the screen, then we need to use something called PETSCII codes. So these PETSCII codes, as you can see, it's easy to get confused by these. But let's take a look at this A here. Now this thing starts at 0, but 0 here, that's nothing, as you can see. So we get down here. Here we have the return key, for example, cursor down, and then we start here at 32, which is just a blank character, so the space character. And then it goes down here, and at address 48 or 30 in hexadecimal, then we get the number 0. It goes on like that, and then we get up here, 64, that's the @ symbol, 65. Then we get an A. So that's the PETSCII codes. Again, don't let this confuse you. We have the screen codes where we're just loading a number and storing it into screen RAM. In that case, we need to use screen codes. Now I'm going to use the kernel function. So now I need to use the PETSCII codes. So if I want an A to the screen right now, I need to use PETSCII code 65 or 41 in hexadecimal. So if I do that, then that's going to give me an A. So I've written 65 here now, the PETSCII code for A. Then finally I run another subroutine at FFD2. That's the one called CRH out, CHR out, character out. So it's a little involved doing this sort of things, but if you use them, if you learn how to use them, then it can actually be really handy. So what we could do, for example, we could make a loop of some kind that would just draw text to the screen. In this case, I'm just going to draw one character. But we could include this little routine here into some sort of loop if we wanted to write a lot of characters to the screen. This is really handy if you need some sort of text routine. But let's take a look at this again. I run this screen clear thing. I'm going to clear the screen. I clear the carry to set the cursor position. I'm going to say set the cursor position. And then by using the X register, I say what row I want to place my cursor. By using the Y register, I say what column to place the cursor. And then finally, when that's done, then I run a subroutine at FFFF0, this thing called plot. So that's where I plot the cursor on the screen. So then I load A with 65, which is the PETSCII code for A. Then finally I run this subroutine at FFD2, this char out, character out. So let's see if this works. So we clear the screen, as you could see. By using this subroutine in the kernel, we clear the screen. Then I set the cursor position at 2 rows down, 1 column from left to right. 0, 1, 2. So 2 rows down, 0, 1 column to the right. So that seems to be correct. And I loaded A with 65, which is the PETSCII code for the letter A. Loaded that into A. Then finally I ran the subroutine at FFD2, that's char out, to actually write the character at the position of the cursor. So that gives me an A here. Alright, I just wanted to show you an example how this works. We're not going to go super into detail because there's a ton of stuff inside the kernel, and you probably should do some reading if you want to do to see how you can use it. But I'm going to link this page where it describes some of the standard kernel functions. Some of these are really handy. So for example, reading input from the keyboard, that could be very interesting. Let's say if you wanted to use the space character in a game for doing something, for example, or if you wanted to program something where you need to press F1, F3 or whatever. So then we have kernel functions to handle that as well. So there's a lot of neat stuff in the kernel, and like I said, it's just way too much to cover in a video like this. So you're gonna have to do some reading about that. But my point here was to show you what the kernel is. So the kernel is an area in the memory. It's occupied, so you can't really store anything there. But there are a ton of routines in there. Now, I say we can't store anything in there. Now, a Commodore 64 programming expert would argue with me. Why would he do that? Well, you sort of can. So, do you remember this thing? We had the character RAM here at address 1000. So, we have a character RAM here. But it's in that area that only the VIC chip can read. Well, it's the same thing here. So under these RAMs, we have this extra area that the VIC chip can read. So this is not going to work without doing something extra, like loading something in from disk after your program has started or whatever. So you can't do this in a simple way by just using the setup that we have now in KickAssembler. So it's a little involved. We're not going to be doing that. But it's probably important that you know that if you get good programming, you want to use the entire Commodore 64 memory, and you're starting to fill up, you run out of space, and maybe you want to store some sprites here at the end. Well, you would have to move the VIC bank to VIC bank 3. So maybe you could say that screen RAM in your case would start at address C1000. So the first address in VIC bank 3. So you could do that, and your screen RAM will be at C1000, and then you could store sprites here from E1000, all the way up to FFFF. Again, we're not going to go into detail about this, so as you can see, it's a little bit complicated, but it's probably important that you at least know that this kind of thing is possible. But for this video, it's important just that you know that the kernel is here from E1000, this area. And for us as programmers, especially now in the beginning, it's probably most useful if you want to use these functions, reading from the keyboard, writing to the screen, or as we have seen a few times now, just clearing the screen. So a lot of great things in there. Now there are even more things now. It's not just these subroutines. There's a ton of stuff going on in the kernel. But as I said, especially for us now as beginners, it's probably this is probably the most useful thing the kernel will do for us. Just using these pre-written routines inside there to handle keyboard input and output, text output, for example. Okay. Well, hopefully I got everything right today. So there was a lot of stuff going on, and hopefully I got everything right. So I actually think we're going to round off today. So I just want to mention that we just have a few episodes now left before we start doing the actual coding for the game, the actual game code. So up until now, we have sort of focused on learning assembly language itself, learning how things work within assembly language. Now we're almost done with that now. So going forward from just a few episodes and to the end, we're only going to be looking at how we are going to make the game itself. And while we're at it, let me just say a few words about how I plan on doing things. So this finished game code is a ton of code. So much code. So I don't think it's a good idea for me to write every single line of code while trying to explain what's going on. I think it's much better if we look at the pre-written code, and I can instead explain what's going on in the code. So that makes it easier to jump back and forth, and much easier for me to explain things to you, so I don't have to write and explain at the same time. And besides that, as I said, it's a ton of code. So that might mean that we won't be writing every single line of code in this course. Now, the thing about that is I've been a little back and forth on this, but I think I landed on this decision that at the end of the course, I'm going to put the entire source code for this test game on my webpage and give you a link so that you can download this whole thing. And then you can study it at your own pace and hopefully learn something from that. So we're going to come back to that. I just wanted to mention that. All right. Well, I think that's enough for today. So I'll see you next time. Bye bye.